Hello friends, and today we will learn how to detect a loop in a linked list. So given a linked list, we need to check if the linked list contains a cycle or not. That means a loop or not, right? And this can be done in two different ways, and we will talk about them one by one. So the very first way is using hashing, right? Uh, So in the hashing, what we'll do, we'll traverse a list one by one, one node by one node, and keep putting the node addresses in a hash set. Right. So if there exists a cycle, we will encounter one node more than one time. And hence we will conclude that there exists a cycle inside our linked list. Right. Let's see how can this work. How will this work when we dry run? So we have our linked list here, and we keep a hash set here, right? The hash set will have node addresses, and then we will start traversing from here. So this will be, let's say we have a pointer p which is pointing to the head, and what we will be doing, we will be just incrementing the pointer p one by one and storing the address inside hash set. Right, this will be our operation. So here, for example, all the nodes, they are located at address 100, 200, 300, 400 and 500, right? Now when p is at 5, we will store 100 inside hash set. Then p will move to 200, so we will store 200 for 8, and then p will move to 10, then we will store 300, then p will move to 400 for 12, then we'll move 400 in the hash set, and then p move to 6, so we store 500, then p again moves to 8 the second time, and when this time we come to store 200 inside hash set, as per its implementation, it will return us false. It will return us false because the element already exists. Right? Now, what is the time complexity for this approach? It's fairly simple. That would be O of n being the length of the whole linked list. What is the space complexity? The space complexity, in the worst case, the space complexity would contain all the nodes in the linked list, and that would be O of n. But what if you want O of 1 space complexity? That means you do not want to use any data structure. No DS allowed. Right, now the things are getting a little bit more interesting. So here comes two pointers approach. So the two pointers approach, we will be having one slow pointer and one fast pointer. The slow pointer will move one by one node, and the fast pointer will move two nodes at a time. Right, and then we'll keep on checking if they both are equal or not. So while both are not equal, okay, and sorry, and none of them is equal to true, none of them is equal to null, sorry, right? That means this condition is to check that we haven't detected any loop yet, and this condition is to check that we haven't reached till the end of the linked list, right? and then fast will be next dot next. This is a pseudocode, might not be working one. We need to add certain another conditions for checking equality and not equality, but this will work in dry run. So let's dry run it. We will have our start pointing here and fast pointing here. Now start, or the slow one will move 1 and fast will move 2. Then we will check if they are equal or not, right? They are not equal, hence slow will move one more time, slow will move one more time, and similarly fast will move one more time with 2 nodes. Now they are not equal, again slow will move one more time, and then fast will move here, right? Then they are not equal and not the end, so slow will move here and fast will move, okay, let me write them again. Slow is here, fast will here, so fast will come here, right? So now they both are equal, right? So the algorithm has detected yet yes, there exists a loop, there exists a cycle. This gives us a cycle, and in this case, although we need just 2 pointers, and because we need just two pointers, the time complexity remains O of n, the space complexity would be constant. And that's how we detect a cycle inside linked loop. Next, we will see how to detect start of the loop inside the linked list. Till then, you think about it. Thank you.